outside wall, the prefabrication of the floor system, which made it pretty hard to fall through, and the use of shaft wall, which allows the metal studs to go up around the openings in the services core prior to the installation of the sheetrock. And so it really worked. Oh, add to that a wonderful safety program on the part of our great client, Port Authority of New York, which we did a great job. These aerial pictures I do not take. The rest of it is pretty much my post photography. So you can see the good ones different than somebody else. To get a sense of the very high aspect ratio of the cameras. This landfill was created from the World Trade Center, and then a lot of landfill was added later to create Battery Park City, a huge development in Lower Manhattan. People talk about iron workers, you know, the construction workers being lazy and all that, but that's not my experience. These guys work really hard. And this is the roof of the 440-foot tower that went on top of the Trade Center. It was fabricated by Montague Betts, but as far as I can see, learned how to fabricate steel in this project. But we had 3 engineers full-time in their shop. And then there was the great day of the topping out ceremony. Here you see, well, it wasn't the last piece of steel, but a symbolic last piece of steel going up. I took this picture and then went inside, rode an elevator up, transferred, rode another elevator up, climbed a bunch of ladders and stairs, and finally got up to the top, and this is what I saw. It was cold, and it was foggy. And nobody knew where this piece of steel was. But I did, because I had been down on the ground. So I explained to the assembled throng where it was. I started out across the steelwork. In this case, it's the roof of the building. There's no prefabricated steelwork. And it was foggy. And it was cold. And the steel was icy. And let me tell you, it was really slippery. And I was walking very carefully. I have a yellow streak up my back. But anyway, I got about halfway across the second beam, and I just stopped. I didn't know what the problem was, but anyway, I stopped. Started to turn around and go back. No, I started forward again. Again, I stopped. And then I did turn around. And behind me were these TV crews. They were walking across the street like this. Like it was nothing. You know, of course, when you have that kind of people behind you, you gain a new courage, or maybe you're too ashamed to show your fear. This is the way the TV camera went over from the Empire State Building to the World Trade Center, but I assure you that's not what happened. But Philippe Petit's a wonderful man. We talked about his crossing between the two towers. In fact, he didn't just cross; he actually performed. It was quite an event, and we became good friends later. And we've done several bits for him. But here you see him. And what he didn't know until I explained it to him was these buildings oscillate in the wind. And they don't do this way so that the cable stays nice and straight, but they do this kind of thing. So he was fortunate that no wind came up. He's alive today and still performing. Great guy. Anyway, we finished it. And felt pretty good about it, actually. And then came 1993, and a bomb went off shortly after noon. We discovered that the bomb had gone off because we had 4 police cars out in front of our offices to take engineers down to the site. So we went down there. Actually, I wasn't there. I was at my house in Connecticut. But discovered from the television that there was this problem in Coleman. Yes. So drove into the city, and the bomb went off about sorry, I'm just coming from Metric World, about 6 feet from Tower 1, and right in this area, right here. The bomb was about the same size as the one that took down the structure at Oklahoma City, almost identical in terms of the capacity. But what happened was this steel wall, if you will, very, very heavy and robust. It just reflected most of the energy of the of the bomb to the south, blew a huge hole through the B1 level, and then caused structural damage about 350 feet was to the south. Still significant structural damage. But the bombers, I think, were trying to bring down the World Trade Center to make it collapse. But the most important thing that they did was they destroyed the airlock around the building. Remember I talked about stack action? Well, when you go through the revolving doors of a high-rise building, you're going through an airlock. That's to prevent the air from rushing into the building and up with consuming a lot of energy and other things. So when the bomb went off, it created a huge hole at the base of the building, and the pressure distribution went from something like this to something like this, and all of the smoke and soot and so forth from the bomb area immediately rose up inside of the towers. And you saw photographs, I'm sure, of people coming out of spaces and clothes totally covered with soot and great human suffering from that event. That was the worst thing that happened with respect to the bombing. The next thing that happened was all of the debris from the collapsed areas of concrete work fell on top of the refrigeration plant. Now it's just a refrigeration plant, you build a new one, but the problem with the refrigeration plant is that if it couldn't be got into operation by June, you'd shut down the World Trade Center because there's no operable sash, no air conditioning, you cannot work in the building. So Port Authority built a temporary refrigeration plant outside. Now the day of the bombing, or the night of the bombing, just before midnight, 4 of us went down to the basement to look at the refrigeration equipment because I want to know what was underneath all the debris. I knew it was there. It was the refrigeration equipment. But 4 was too many people. We had our flashlights were too small. So the next morning, I had a couple hours sleep. I went down by myself and looked at the refrigeration equipment. These pressure vessels were designed to pump water from the top of the World Trade Center. These are not, pieces of sheet metal or something. And they looked in pretty good shape to me. But Port Authority still went ahead and built these plants, which were never used. We brought people out of retirement. The average person in the office worked for 90 hours each week. We served breakfast, lunch, and dinner in the office, working for breakfast, lunch, and dinner. These were working meals. The devastation was pretty bad, and these columns were supporting a hotel. And those of you who know about columns realize we designed them with lateral supports, and when you take the lateral support away, there's the prospect of buckling. So it was a mess. Remember all this heavy stuff that's sitting on top of the refrigeration. And so these columns were actually braced. They were fixed-ended, if you will, by being buried in this mound of debris. But, you know, it's hard to calculate the lateral support from debris, so that night, Friday night, I worked on braced these columns. Next morning, made the sketch, had the fabricator into our office at noon time. They agreed this was a good way to do it. Looks pretty neat, right? Yeah. The reality was not quite so nice, but it worked. I mean, you know, it was possible to do this really fast. We thought that we could start on Sunday, and the steel was delivered on Sunday, but this was a crime scene, and we had a sort of a summit meeting because there were 5 different police jurisdictions. We had a summit meeting about every 3rd day because someone there would say, well, you can't go into that part of the work. And our response was very straightforward. You can't go there either because we controlled where in the project people could go. So we had this sort of a standoff every 3rd day. But on Monday, we were able to get a hole through the floor and start lowering people down. In fact, this photograph was took from a kind of bosun's chair, dropped down through a small hole into the middle of this great abyss. So this was the situation. Refrigeration equipment down here, a lot of rubble piled on top of it. And one of the exciting things is that this support, which was really critical to this the slurry wall, which keeps out the Hudson River, was working because the slabs dangled down into the debris. So it was the concrete structure holding up the refrigeration equipment, holding up the debris, holding up the collapsed slab, which was in fact keeping up the Hudson River. So the whole logistics of take out this, do this, so it represented thousands of drawings that we produced in our office. And much of the work we did was just that. It was not so much designing things, as it was sorting out what could be done in terms of the actual operation itself. Those of you who know about shock waves, these are drop panels in a very good picture. Drop panels for a flat slab system. The pressure wave would come this way and hit the forward edge of the drop panel. I'd pretty much leave it there, no big deal. But get to the leeward side, and the shock wave going on, it would put the concrete in tension and ripped off most of the back sides of the drop panels for about 200 feet. This exciting structure is there because there was a big fire some 5 years earlier, and rather than try to evaluate the quality to reinforce these fields over, we just bolstered the slabs with these elegant devices. Much of the repair was like this. It's just knock out the concrete, which was all cracked and broken, jack up the slabs, and reconcrete it. Now the bomb went off 6 feet out this way from here. There was a diagonal brace here, and this one, and a column. This diagonal brace was made like a T-section with bolted together in the center of the web. And if you look at the picture carefully, you see the flange of the T goes right by the column. Doesn't intersect the column. It goes right by it, and it's a kind of an applique. And the detail works extremely well because these columns are not exactly where they're supposed to be. They're always out of position. They're twisted a little bit, and so forth. So this detail allowed us to carry very heavy loads through the system without having actually connected to the column itself for large forces. Anyway, this brace went inside, killed 2 people. The outside piece fell into the hole and was never found. It just got carried out with the debris. And the other one, here you see a view looking at the other one. You see this big crack here. This took place, of course, because of the impact loading. You can't do this in a testing machine. You've got to like hit it with a giant hammer. This piece, no one knows where it went. It's a spiritual place. And this one was hidden by the ironworkers because I admired it, and they I stuck it off in the corner where the Port Authority couldn't find it, and then later on they took it out to my house. Here you see it when it was first erected. So there were lots of cars. The place was full of automobiles. This slab used to be up here. I took lots of pictures of automobiles because imagine if you had an automobile in this space. Wouldn't it be great to have a picture of it? Well, I took pictures, particularly if I did license plates, took photographs of the automobiles and sent them to the people who owned the cars. There's hundreds of them thank you letters. Wherever there was structural steel around, the concrete suffered more. All of the telephone conduits from Lower Manhattan went to the telephone company building through the basement of the World Trade Center. This is a tiny fraction area. So we put a team to work around midnight, and at 9 o'clock in the morning we went down with the drawings of how to hoist all this conduit back up, get it off of the cars, because you have to remove the cars before you can get to the structure, and you had to inspect the cars because that's what police do. Anyway, interesting enough, not a single wire was broken in the operation. I blame that on the contractor who was being too careful. We had all these, this is a terrible picture, but these bomb squads, this was bomb squad, they were out there with dustpans and whisk brooms going through the rubble looking for pieces. Later on, I testified for 2 days in the trial of the 5 who were convicted of this matter, and these people picked up incredibly small pieces of that van. Unbelievable. Big pieces, little pieces. They had almost the whole van. So every time you got near structural steel, the concrete broke up very badly because it could not deflect away from the pressure wave. Remember, this is not a static loading that's taking place here. It's a more or less instantaneous loading. Anyway, it was finished and this memorial was built. I always hated the memorial, but it was built, and again, we sort of went back to sleep and forgot about the location. And then Minoru Yamasaki came down with cancer, and he was in Sloan Kettering, which is a famous hospital in New York City. I went to see him every day. And he wanted me to look after the Trade Center. And not only that, he wanted me to make sure that the young engineers would continue to look after the Trade Center. Anyway, then this is this photograph is taken from our offices. If you saw the slow motion videos where they were just looking at the images one at a time, you discovered that the whole airplane disappeared into the south facade and could not be seen, and then the great fireball erupted. So this is the north face of the North Tower, and you see that a very substantial amount of structure was removed, and yet the structure above was able to span over this huge opening without seemingly without stress. This is a sort of blow up took place. Okay, a lot of you know about energy and impulse and momentum and all those things, and I don't want to have a big discussion here on that subject. How much of the energy went into crumpling the airplane, and how much it went into ruining the buildings, and how much it went through and came out the other side. This is just to give you scale. The Mitchell bomber that hit the Empire State Building had this much energy. It's just a little mark here. We designed for the 707, but it was more or less fuel-empty 707 because it was a landing 707, and it was lost in the fog, so obviously they didn't have the hammer down on the throttle. And this is, in fact, the kinetic energy of the aircraft that struck the building. So you see it was many times larger than the design criteria. The fire safety issues in the building were not our responsibility, although, you know, we dabbled in most everything. But in any event, I don't think anyone knew how to, first of all, I don't think anyone knew what happened when you crashed a 707. All those tests were done later. But in any event, this is the amount of fuel that was in the Mitchell bomber, and this is the 707. This is what we designed for, and this is what was in the 767 that hit the aircraft. And again, this is not a good comparison, but the bomb at Oklahoma City, which is pretty well documented, even the one at the Trade Center, about 200 liters of fuel compared to 45,000, 46,000 in the 767. So you see a huge difference in the amount of energy released. And now we go, that's, if you will, the kind of good news. The bad news now comes forward. This is just an idea what that V-25 would look like. It's just about to get. This is our 707. It's a 767. It's the 747, which is actually wind spread a little bit bigger than the floor space. And this is the new Airbus. And now, in kinetic energy, we can't get the Mitchell bomber because it's too small in terms of the amount of energy released. But this is the 747 as compared to the 767, and this is the new Airbus. In terms of fuel, not so startling, but still, when you think of what happened to the Trade Center with the not quite 2 tons of TNT, which is about 200 liters of fuel, compared to the over 300,000 liters that comes with the new Airbus, you realize that it's not practical or sensible. I mean, you can design anything for anything, I guess, but you can't design buildings that you or I would ever want to live or work in for this kind of circumstance. Totally out of the question. engineers have written saying, well, you know, it's patently ridiculous if the project wasn't designed to take the impact of the aircraft. And I understand what's in their mind. You could land a 767 inside of the World Trade Center. It would look like this. This is the North Tower. Remember, the plane is traveling in this direction, the strong axis for the columns. And in the South Tower, in this direction, we're going to the weak axis of the columns. And then this is the time temperature curve. This is standard ASTM time temperature curve for a fire in a building. And this just took it out of the petrochemicals of the offshore structures generally. What happens if you have a petrochemical fire? So you see, it's very different. People said, well, you should use concrete fireproofing, and this shows you something about the strength versus temperature of concrete versus steel, and you see there's not all that much difference. What happens when you put this high energy on the concrete, it sort of just goes off like the popcorn. It just flies away. Indeed, if you look at the columns of the Pentagon, which were square with a round cage of reinforcing inside, after the impact, the columns were round. That is, all of the outside concrete gone. So the steel was, the reinforcing steel was then exposed. Okay, this is the area that was at least partly damaged because of the circumstances of the rest of September. To give you an idea of the cost, some of this is estimated, but in the World Trade Center attack, this is going backwards because you're guessing, and about $50 billion. Hurricane Andrew, the largest to date, almost $20 billion. The Northridge earthquake, almost $15 billion. Most of the big catastrophic events are associated with windstorms. So the project looks something like this: the North Tower, called Tower 1, South Tower, Tower 2, the hotel, Building 3. You should memorize these numbers. This is Building 4, 5, 6, and then across the street is Building 7. Now, we were not the engineers for Building 7, so I'm not going to talk about that. I'll show you some pictures. We did the base of the hotel, but other engineers did the superstructure on top of it. So this is Building 4. You see a piece of the, or part of the North Tower fell down and just wiped off the corner of the building. Just gone completely. If you go between Buildings 4 and 5, you see some of these wall panels. You recognize the 3 columns wide. Fell down and the building was able to support them. You see these side columns are all bent and buckled and so forth. That's mostly from the fire that took place. Fortunately, the structure was very redundant. There's a moment frame that goes back into the building, and then the columns on the outside. And there was a load distribution between the two so that you could take out columns or take out frames and still it wouldn't fall down. There was a huge sculpture piece in the middle of the plaza. It's another thing I've always hated. You won't believe it. We designed the crate that this thing came in. I sent an engineer to Germany to supervise the crate. It was that expensive. I came here, and then after the event, it looked like this. So it did pretty well. This is the east wall of the north. The east wall of the North Tower. This is part of the services core of the North Tower. Looking at what was the South Tower. You can see it was not a real safe place to work. All kinds of things hammering out and rooted in who knew what. And this wall panel was spliced up here someplace. And nobody knew the condition of the bolts, but still people were working through the area. Because at this time, this photograph was on Sunday following the event. I was in Hong Kong when it took place, so with the good help of the government of the state of New York, I was able to get back to New York really fast. But it was Sunday when I took these photographs. they were concerned, of course, about the people. So this is building 5. You can see that this is a piece of the tower which failed inside, and rigid frame going inside, buckled columns, and the great tower. Where really heavy structure came down, it would just wipe out the building. So you see here a whole bunch of structure fell and just took out the, in this case, the south face of the Tower 5. Our people, the respirators were mandatory. We didn't let people go out on the site without them. There was huge asbestos abatement programs that was there, but so almost all of it was gone, and there were regular monitoring in the air. The Port Authority was fantastic about things like that. But still, it was extremely dusty. We have the 47th and 48th floor building looked down onto the site, and we just taped up all the windows because it keeps the dust out. That's building 7, which is just to the north of the project. And people have asked me about this pile of dirt. Why is there a pile of dirt in the building? Of course, concrete is made out of sand and gravel, and when you pulverize it, you get back sand and gravel, which looks like dirt. So this is really pulverized concrete that you're looking at. You see it everywhere. This is, again, next to building 7. This building stood up pretty well, except for a little damage. This building 7 collapsed right through here. Here you see one of the transfer girders from building 7. And this is the Verizon building, the telephone company building, part of the transfer system. We got left in place when it collapsed. This building burned 6 or 8 hours and then collapsed at the end of the day. And will be the subject of intense scrutiny because I believe it's the only major building, 47 stories, the only major building that's ever collapsed in fire, just with no other reason. The towers, of course, collapsed.